Activity 4. Graph of y equals x squared and its transformations. This activity is part of Unit 3, Properties of Quadratic Relations. Algebraic representation of a relation. Remember, linear relations can be expressed in slope and y-intercept form. That form is y equals mx plus b. It can also be expressed in standard form, ax plus by plus c equals 0. Different forms of equation are used for different purposes. So for example, y equals 3x plus 4 is equivalent to 3x minus y plus 4 equals 0. These are both equations of the same line. M equals 3, we can find that from this form. And we can also find out b, or the intercept. So from this first form, we can identify the slope and the y-intercept. Using standard form, we can identify a, b, and c. We often use the slope y-intercept form of a linear relation when graphing by hand or by using technology. The slope m allows us to easily recognize the steepness and direction of the line. The slope here is 3. The y-intercept b allows us to easily recognize the point where the line crosses the y-axis. So it's easy to use this form to graph this line. Algebraic representation of a relation. Quadratic relations can also be expressed in a number of ways. We have standard form, y equals ax squared plus bx plus c. We have the factored form, y equals a times, in brackets, x minus r, times, in brackets, x minus s. We also have vertex form, y equals a times, in brackets, x minus h squared plus k. Each form has its own particular advantages and is best for finding certain characteristics of a parabola. For example, in the standard form, it is very easy to identify the y-intercept. C is always the y-intercept. We will explore each one of these forms and how to convert between forms. But in this activity, we will be concentrating on the vertex form to understand the transformations of a parabola. The vertex form, y equals a times, in brackets, x minus h squared plus k. Let's look at an example of a quadratic relation expressed in this form. Y equals negative, in brackets, x plus 3 squared plus 7. We're going to look at each one of these coefficients. Think of this. We have our quadratic expression in vertex form, and remember that it corresponds to these coefficients represented by a, h, and k. So our a is negative 1. Our negative h would be negative 3. And our k is 7. Remember that h is always the negative of what's here. So since this is plus 3, our h would be negative 3. And there's the explanation. Negative h is equal to positive 3. We isolate to get h, we remove this negative, and change the signs. A, in this case, is negative 1. H is negative 3, and K is 7. Let's look at another example and identify each of the coefficients A, H, and K. Y equals x minus 6 squared.